you know, like you can work out the acceleration. Variable acceleration, acceleration's changing. So velocity time graph, here you can see increasing acceleration, here decreasing. Okay. Yeah, so I suppose if acceleration was 0, then velocity would be constant. Yeah. All right, let's try this.
So that's just me subbing in 2 for 2.
Yeah, and any idea about B?
So if I say moves in a straight line such as this, so I think what I'm gonna say would be something like S is 10.
No.
Am I saying T is T or stuff, or?
No, it's not suvat. Suvat is when you have constant acceleration. So suvat doesn't work for this. So first one, T was 2.
Yeah.
That gave us 10 seconds. For this one, we want the time it would take to return to the origin.
Would it be 2 times 10?
It would be S is 0. So S is 0 at the very start and when it returns.
Yeah. So that is just 0. I got roughly 1.22 seconds.
T equals 1.22. Let me just write down. Showed my working out. And another possibility is 0, I think, is it? Is it root? Is it root 3 over 2?
I put into my scientific calculator. It just gave me this number.
I just want to see. 1.22. Yeah, great. We're good. Okay. Any idea about this? Hang on, before we do that. Let's do this next.
Okay. I'm assuming I need to make V equals to 0.
No, the velocity was 0. We want the velocity.
Oh, sorry, T is 0.
Yeah, T is 0. When T is 0, what is V?
24.
Yep. How about B?
Is it now V is 0?
Yes.
And so that will be T is either 6 or 2.
Okay. C.
Just sub in 64 for V and then put into my calculator.
Right. You might not get 2 answers though. You might have to do something with it to get both of them. Any idea?
Should I make minus 64, so 0 equals to 2t squared minus 16t minus 40?
Yes. And so you have to make it equal to 0. and then you can use the solver just in case you don't get all the solutions the other way. And you get two values for t, whatever they might be. And how about any idea how we do d?
Is it? Can I? Should I just be solving your numbers for t until I get the highest velocity or something? Or?
So you could, like into a table of values or something.
Yeah.
You can also just graphical calculator, put that in, and just see where it's at the highest between 0 and 5.
And so,
if you're confident with it.
Yeah.
Or you can try it out if you want, it's up to you.
I'm not entirely sure. So I've put it into my graphical calculator, and I've got the curve, but I don't know what I need to do now.
So between 0 and 5,
Yeah.
what's the highest y? That would be maximum v.
Oh, right. That would be like 24.
And so, and at what time is it?
0.
Before at t equals 0. We had that one. And there it is. Great. Yep. And let me think about this. Okay. So let's take a look at this one.
Should I put this into my calculator again?
Yeah, why not?
Shall I say my highest value for 0 between 4?
No. Why is it restricted from 0 to 4? Why can't time be 5 or something?
Oh, because it becomes negative.
Yeah. Distance can't be negative. Something like that. So this models the distance from the start that the train has travelled, but I think when t is more than 4, it would have to be negative, and you can't have negative distance. Yeah, grand. I think I'll put that one here. I'm just gonna move it. I think it worked out right. Moving that there. Okay, let's see this one. To show that type of question. So, alright, how do we show this?
Do I need to make t is 0?
Well, that would just be starting.
Oh, actually, x is 0, sorry. Or...
Yeah, you could make x 0.
And do I now just need to solve for t?
Yeah, go and try it. So let's see this. Page 10. Variable acceleration. So, 10 .
I got t is 0 and 2.
T. No. I don't like that. Okay. But how do we show that x will never be negative?
So would I now need to sub in the 2 and the 0 in the initial equation and show that both x values will be positive?
Well, they'll both be 0. Let's see. Can you factorize this bracket? Don't think you can you? To show that question, write this second bracket. Well, let's see. Yeah, write this second bracket in completed square form. What would it be?
So that will be like t minus 2 bracket squared minus 16 plus 4.
Yeah. So that's minus 12. Let me see. No. And minus 2 squared plus 4.
Yeah.
So it's literally just t minus 2 squared. And that's how we're getting t is greater than or equal to. That's not showing anything. That's just saying it. Oh, they just wrote it in the completed square form, right? So x is greater than or equal to 3t times this for all values of t. Because t can't be negative. All right. T numbers, and then t is greater than or equal to 0. All right. Weird. Let's see this. How would you go about doing part C?
Completing the square.
No. You could, but easier way.
I'll put it into my calculator.
Yeah, between 0 and 5. Okay. So this one is like extra difficult. The change in the displacement in the third second. I'm going to leave that. Given that the model is valid when it's find the value of t. So we need to find this maximum value for t, capital T, and s has to be greater than or equal to 0. So we have to find the restriction thing. So any idea how you do that?
So I'm not just putting it into my calculator.
So I think you could. However, let's think about this. I'm going to write it the other way. 5t squared minus t cubed is equal to s. They're saying s is greater than, where did I see that? S is greater than or equal to 0. So therefore this thing must be greater than or equal to 0.
Yeah. Oh, I can just put it into my calculator now, my scientific one, with like the inequalities thing.
Yeah. There you go. This is cubic. No. Inequality.
I got x is smaller or equals to t is smaller or equals to 5.
And so what is the value of t?
5.
Yeah, t is 5. Great. Let's see. Here we go. T is 5. And I'll get that one as well. Let's see. 6 meters was the first one. Yeah, that was okay. T is 5. The times when it's instantaneously at rest. Yeah, fine. Alright, let's try this one.
So is that just the same thing?
Yep.
So is that just me doing 3t squared minus t cubed is smaller or equals to 0?
Greater than or equal to 0.
0, okay. And then go into my calculator.
Mm-hmm.
And that will be I got so t is equals to 3.
So t is equal to 3, and it says explain your answer.
And then would I just say that t's got to be equals to 3 because if it's any bigger, it'll be negative or something? Or
Yeah. T is greater than or equal to 0. T is less than 0 when, I don't know, capital T is greater than 3. So t equals 3, something like that. There we go. Let's see this one. The greatest speed. Fine. Okay, functions of time. That's done. Okay, using differentiation. What is this about? If you have if you differentiate displacement, you get velocity. If you differentiate velocity, you get acceleration. Let's try it. How about this?
sorry, could you repeat that, please?
So let me see. So maybe, do they have a nice little thing? Yeah, it's nice enough. Yeah. So let's take this one. So velocity is ds by dt, like change in displacement, derivative of displacement. And then acceleration is the derivative of velocity, which is the double derivative of displacement.
Okay.
And it's because it's like 1 is to the power of 2, 1 is to the power of 1, 1 is to the power of 0. Let's try these.
Do I need to differentiate here?
We are given the displacement. We want velocity. Yeah, velocity is the derivative of displacement.
And so am I doing 40 cubed minus 32?
Mm-hmm.
And then do I just sub in 3?
Yep.
And that will be 76.
That's 76 meters per second. How about B?
Is that now just me doing 0 equals the differentiation.
Yep.
And so that will be. Yeah, I got 4 bad numbers.
Shouldn't. Just do cubic.
Yeah.
I could always do it manually, but 4, 0, 0, and then minus 32.
Yeah.
That's what I'm getting.
Oh, I did it to the power of. Oh no. It's because I didn't even use the differentiation. I just used the first bit t to the power of 4, etc.
That's when displacement is 0. This one is. You even said it.
I know.
C.
Is that just me subbing in 1.5 as a differentiation?
No, acceleration.
So the formula for acceleration was dv dt.
Mm-hmm.
So will that just be me differentiating that second equation again?
Mm-hmm.
So that'll be 12t squared. And then I'll just sub in 1.5.
Mm-hmm.
And I got 27.
That's 27 meters per second. That seems very fast. Let me check this. 4, 12 t squared. 27. There you go. Great. Yeah. All right. Let's see this one. Yeah.
So I think here I'm just differentiating this again.
Mm-hmm.
And so that will be 6t squared minus 8.
Mm-hmm.
And then I just sub in 3 into the t value.
Yeah. And B.
And I think I'm just differentiating that again and then subbing in 2 for t.
Yep. I think you're good. All right. Let's try this one.
So I think I need to do double differentiation, then equals to 4.
That would be if it was S equals. This is V equals.
So if I do do I need to differentiate it once?
Correct.
And so that will be just k minus 6t
Well done.
equals to, yeah. And so is that 4 equals to k minus 6t, or?
Correct. And what is T?
Zero.
Mm-hmm.
And so k is 4.
Yep. And how would you do B?
Do I now need to do? Oh no, am I now double differentiating, or?
You'll never double differentiate acceleration. Sorry, velocity. You would double differentiate displacement to get acceleration. You would single differentiate velocity because it's already been differentiated, if you like, to get acceleration. So when the acceleration is instant, now find the acceleration when p is at rest. How would you do that?
Do I do 0 equals to 4 minus 6t?
That would be when the acceleration is 0. When the particle is at, we're trying to find acceleration.
I'm not sure.
When the particle is at rest, velocity is 0.
And so it's now going to be 0 equals to kt minus 3t squared.
Yeah, what's k?
4.
And so it says, use that one. Minus 3t squared. Okay.
And so if I now solve for t, I get 4/3 and 0.
T is equal to 4/3. All right, is that it?
Do I need to sub that back into k minus 6t?
Correct. What is k?
And, sorry, 4 minus 6t.
Yeah.
And so that gives me a is 4, or a is minus 4.
Minus 4. Plus it says using the value find acceleration. Is there one of these that we should reject or something? A particle. So maybe for one of them t is 0 or something. I don't know. It's minus 4. Let's see. When t is 4/3, it's minus 4. When p is next at rest, acceleration minus 4. Oh, because they gave us the first one. Ah, yeah, the initial acceleration is 4. We have to find the second one, so minus 4. Great. Minus 4 meters per second. Grand. Yeah, so that one, you have to use if it's at rest, velocity is 0. you have to use that to get the time when it's at rest, and then sub that time into the acceleration one to get the acceleration. Yep, it's good on. Let's try this one.
So, does that make t 0?
No, we're trying to find t when it's at rest.
Is s 0?
No. S is displacement. There's only one more possibility.
I differentiate.
V is 0. Velocity is 0 if it's at rest.
So if v is, so I do 0 and then equals the differentiation.
Yeah.
Which will, first of all, if I expand the brackets, will be 2 over 3 cubed minus 7t squared plus 20t plus 30.
Okay.
And then if I differentiate that, that will be 2t squared minus 14t plus 20.
Mm-hmm.
And so if I put that into my calculator, that will give me t is 5 or t is 2.
T equals 2 or t equals 5. Find the distance between the points.
And so I now need to sub in the 2 and 5 into the initial equation.
Yep.
And so that will give me third. So when I subbed in 2, I got 47.3 seconds.
When you subbed in which one?
2.
So let's say 47 and a third. Okay.
And then I'm now getting, when I sub in 5, I get 38 and a third.
Okay. We want the distance between them.
Do I subtract them both from each other?
Yep.
And so that will give me 9.
Sounds alright. And so that, and we get like the magnitude of that. And that is 9 centimeters. And B.
Am I now doing 47 and a third squared plus 38 and a third squared all square rooted?
No.
Or is it? Oh, acceleration. So acceleration is the different. I need to differentiate again first, don't I?
Well done.
So that'll be 40 minus 14.
Mm-hmm.
And so now, am I subbing in both of those t values or something? Or
Yep.
and so that will be. So when I subbed in 38 and a third, I got.
No. Those are S values.
Oh yeah, sorry. So if I do. So when I subbed in 2, I got -6. And when I sub in 5, I get 6.
And so the magnitude of the acceleration?
6 squared plus 6 squared, all square rooted.
No, it is just 6. Like if it's +6 or -6, then it's just 6.
Okay.
6 meters per second squared, I believe. Oh, centimeters per second squared. And the other was 9. Grand. So let's see the distance between them when it's at rest. So differentiate to get velocity, make that equal to 0, find the 2 times, and then sub those in to get the distances, and then the difference. Yeah. And then it's a bit misleading. Well, you know, it's just the language, the magnitude of the acceleration. So once you see 6 or -6, they just mean 6 in general. How would you start this one?
So is. Do I need to sub in all values for t or something here?
No. For this one, you found the distance between the points at which the particle is instantaneously at rest.
Yeah.
This one, the distance between the points when the printhead is instantaneously at rest.
Do I need to differentiate first?
Yep.
So that should start off that. So the normal number is t cubed minus 15 over 4t squared.
Over 2?
Over.
Oh, sorry, yeah, sorry. Yeah.
And plus 3t plus 30 over 4.
Yeah, I know.
And so now if I differentiate that, that will give me 3t squared minus 15 over 2t plus 3.
Mm-hmm.
And so this will give me the velocity.
Mm-hmm.
The printhead is intense. Am I now making t0?
No, we want when it's instantaneously at rest. What's 0?
V.
V. Yep.
And so and I got t is 2 or t is a half.
Okay.
Do I now need to sub in both those values into the initial equation?
Yep. And what would you do with your answers?
Subtract them from each other.
That's it. That's how s of a half minus ds of 2, or whatever way around it would be. And you would get your answer. Yep. Let's see. So they differentiate it, make it equal to 0, a half or 2, and they sub those back into the original and subtract. Yep. Okay. How would you do A?
So that will just be differentiating and making v 0.
Yep, and then you solve for t. Great. And then the greatest speed, that's okay. The greatest speed between that and that, yeah, it's alright. Find the value of k. So these are the important ones. Let's see this. Alright, how do we do this?
So I think, shall I first differentiate this and get 3kt squared minus 10t, and then make v equals to 8, then do 3kt squared minus 10t minus 8.
And
I know what 1 is anyway, so I just do 3k squared minus 10.
3k 1 squared.
Yeah, oh sorry, it was just 3k, yeah, just minus 10.
That's it.
And I get 6k6.
3k is 18. Yeah, k is 6. And then how would we do b?
And so I think here I needed to do differentiate again.
Mm-hmm.
And so now I know what k is. I just do s equals to 6k cubed minus 5t squared plus 12. And then I need to differentiate that twice.
We already did it once.
Yeah.
So we said 3k. K is 6, so 18.
And then now I need to do 36t minus 10. Sub in rest, and then it's not t is 0, is it?
No. When it's at rest?
Is that a 0?
No. If it's not moving?
Is v 0?
V is 0. Yep.
Yeah. And so does that mean I now need to do 0 equals to 18t squared minus 10t?
Yep.
And so I then do And my two values for t are 5/9 and 0.
Mm-hmm.
And I then sub both those values in for a equals.
Mm-hmm.
And I've got a is -10 or a is 10.
Right.
So does that mean now that a is equals to 10?
Yeah, the magnitude, absolute magnitude would be just 10. I think you've got it. If it's at rest, velocity is 0. That's all there is to it. That's what it means, 10. K6. Sketch a graph, that's alright. Find the values of t and the corresponding values of v when the acceleration of is. So what is 0 for this one? For B.
That means that V is 0. Oh no, A is 0.
So strangely for this one, A is 0.
Yeah.
Solve for t, and then sub those into the. Oh, hold on. Find the values of t and the square value. Yep, and then just sub it back into the original. So it's alright. That one.
Maybe it's a.
It's not bad. I just want to see maximum minima. Yeah. Right. Test today is best today. Test our best. Let's do this.
So I think here it's V is 0.
Yeah.
And so that will then do. And t is 5 or t is 13/4.
Okay.
And I think here I'm just subbing in 9 instead of for V.
Yep.
And so if I make it now equals to 0, that will then become 2 minus 13 plus 6. And I get t is 6 or t is a half.
Okay.
And for here, I think I need to do. Oh, I can just put this into a graphical calculator, can't I?
Yeah, I don't like the look of that 5 marks though. But they haven't really given us. You can use table values, graphical. What they really should do, I think, is a method that's in the next section, which is you would differentiate again, make it equal to 0 to get the maximum. So what is this? This is velocity. So acceleration at the maximum would be 0. So that would be 4t minus 13 equals 0. So t equals 13/4, which is that one. And so what is the velocity when its time is 13/4? Velocity is 0. That's... Did I do that right? let's take a look. See, 15 meters per second. Graphical calculator it is, or table of values. Let me check mark scheme. I'm checking these mark schemes. So,
Was I meant to differentiate here?
no,
Okay.
no. I don't know, but let me just go back. The greatest speed is D. D, they sketched a graph. Range is that. Sketched a graph. Alright. That's alright. Do you know what you could do actually? Nah, let's not. How would you do? Hang on, let me just see what we did there. Instance arrest. Yeah.
By the way, do we get the formulas for V is ds and dt and A is dv dt?
I doubt it.
Okay.
It's literally the derivative. You know, it's like s is to the power of 0. It's like centimeters to the 0. Let's say meters to the 0. What is it? Velocity will be meters per second to the 1, minus 1, and then acceleration meters per second to the minus 2. Let's see. Find the values of t. What's this? The rest? Greatest speed. How would we do part B?
So I think I need to do double derivative and then sub in 2 for t.
So we already have one derivative.
And so if I do 12t and then sub in 2, and so I think it would just be 24.
That is 24 meters per second squared. Okay, using the value of k, we did it. The time when p is instantaneously at rest. How would you do part A?
Differentiate and make v equals to 0.
Don't need to differentiate. It is v equals. And so you just make v equal to 0.
Yeah, okay.
Because it's not always s equals.
Okay.
Sometimes it's given in terms of v. We did that. Yeah. And so, yeah, how was that for you, Andrey?
That was good, thank you.
And so, if you want, we can continue this next time or something else. Do you have any preference?
Yes, continue this next time, please.
Okay. Any questions from me in general?
I don't think so.
All right. Well, well done, Andrey. You did great. I look forward to talking again next time.
Thank you. See you on Friday.
All right. See you then. Take care.
Bye-bye.
Bye.